Question number one. A generative AI engineer has created a RAG application to look up answer to question about a series of fantasy novels that are being asked on the another web forms. The fantasy novel text are chunked and embedded into vector store with metadata, page numbers, chapter name, book title. Retrieve with the user's query and provide to LLM response. Want to more methodically choose the best value. Which two strategies should the generative AI take to optimize their chunking strategy and parameters? Option A, change embedding model and compare performance. B, add a classifier for user query that predicts which book will be the best contain the answer. Use this to filter retrieval. C, choose an appropriate evaluation matrix and experiment with the changes in the chunking strategies such as the splitting chunking by paragraph or chapter. Choose the strategy that gives the best performance metrics. D, pass known question and best answer to LLM and instruct the LLM to provide the best token count. Use summary strategy of the best token count to choose chunk size. E, create LLM as a judge matrix to evaluate how well previous questions are answered by the most appropriate chunk and optimize chunking parameter based upon the value of the matrix. So the key goal is optimize chunking strategy. For example, paragraph level, chapter level chunks. Make mathematical data-driven decision rather than relying on the institution. Option A, change the embedding model and compare performance. What it does, test different embedding model to see which retrieves better result. Problem, this is not optimized chunking. It's changing the embedding entirely. So we do not have to change the embedding model here, right? Vector not directly related to the chunking strategy itself. So change the embedding model is not work here because our goal is to optimize chunking strategy. Right. So option A is incorrect. Option B, add a classifier for user query that predict which book will be the best contain the answer. Add a classifier for user query. Add a filtering step to retrieval. This is the meaning of that one. This modifies retrieval, not chunking. Means retrieving the answer. This work, but it not work on chunking. Option C, choose an appropriate evaluation metric and experiment with change in chunking strategy, like paragraph versus chapter. Choose the best performative metrics. So here, directly measure how different chunking strategies perform using the formal metrics. So yes, it's a uh, it is a part of the chunking. Means here we can use how we can get the best chunking. So yes, this will exactly what is the need. Option D. Option D is the past known question and best answer to LLM and instruct it to provide the best token count. Use the strategy of the token count to choose the chunk size. Use token count strategy from the LLM and select chunk size. This is the question. This is the option saying, but no. Token count alone doesn't. The token count alone doesn't measure retrieval query or whether answer are accurate. So this is also not correct. E. Create LLM as a judge metric to evaluate how well previous question and answer by the different chunk. Optimizing chunking parameter using this matrix. So yes, use the LLM to score answer quality for the various chunk size. Yes, this is our question asked. This is another good way to measure the chunking quality in the practice. So yes, option E and option C. Create the LLM judge metric to evaluate how well previous question. So this is the correct. And option C, choose the appropriate evaluation metrics. Yes, to experiment change the chunking strategy. C and E is the correct answer. Question number two. A generative AI engineer is designing a RGM application for answering user question on technical regulation as they learn the news code. What are the steps need to build this RAG application and deploy? So the goal is RAG pipeline. RAG pipeline generally follow some steps, like six steps are there. One is the ingest documents, means collect the data from the source. Second is index and store as embedding in vector database. Third is user submit query. The LLM fetch relevant chunk. Then fourth is LLM generate a response using the retrieval context. And fifth is evaluate the model, check response quality. And sixth is the deploy using model server. So here option A is ingest document, then index, vector search, user query, LLM retrieval, evaluate model, LLM generate. So problem here is order is wrong. You cannot evaluate model before generating the response. Right. Here we are generating the response and model is not evaluated. So option A is incorrect. Option 2, ingest, then index the document, vector search, user query, LLM retrieval, and LLM generate response, then evaluate the model. Yes, this is the correct flow. So option B is correct. Now come to the point, say option C. This is ingest, then index, then vector search, then evaluate, then deploy. Here, missing key is user query and LLM response before evaluation. So incomplete. Option D. User query, ingest, index, vector search, retrieve, generate, evaluate, and deploy. So ingest and indexing should be happen before the user query, not after. So option D is incorrect. So correct answer is option B. In short, if we talk about then first we have to prepare your document, then allow query to hit the retriever and LLM, generate the response, and then we have to evaluate them, then deploy. After you know its work, then only you deploy. So option B is the correct because as I said in earlier, the steps is engage the document. So this is the first step. Yes, ingest document is the first step. Then indexing the source and embedding, indexing and store embedding in vector database. That is also correct. Means first we index the document, then we store in the vector database. Then user submit the query. Once user submit the query, we have to fetch the relevant document. So step 3 is also correct. Step 4 is LLM generate the response basis of the your query. That is also correct. Once LLM generate the response, then we can evaluate what the model give the response. Is it correct or not? Once we evaluate that the quality of the model is good, then yes, we can deploy. So option B is the correct answer.